Okay, recording has started. Just so everyone knows, if you don't want to be recorded, please let me know. Um, but this is, I'm thinking this is probably going to be the last of this series of events. It won't be 100% done when we get here, but it'll be done enough that uh, we'll be getting into some like really boring, tedious stuff, like, you know, the final kind of play testing, polishing into production kind of stuff. And that kind of stuff is not as much fun to see on a tutorial because like it's just gonna be sitting there like playing the puzzle a lot to make sure that it works and that kind of thing and debugging networking issues that come across. So we probably won't do another one beyond this. We want to get to the point where we can like move groups around and attach groups and Paul, I think your microphone is.
Oh, turn your
Sorry,
mic
yeah,
off.
mute and mic. Sorry, it's someone talking outside that's picking up.
Yep. So we want to get to the point where we can move chunks around and not just individual pieces, and that the puzzle recognizes when it's been completed. And if we can get through that part today, then we'll basically have as much as is interesting to see on these videos, and so we'll move on to something else after that. We will still kind of finish this up in the background and get it on GitHub, but it just won't be fun to watch endless play tests of it and things like that. Although it's getting there, I was messing with it before the call because I like to run Unity once to make sure it's not going to crash the first time. And I found myself like sitting here trying to put the puzzle together and immediately being frustrated by not being able to move chunks around. So we are going to need to find a different picture. This is really difficult to
Yeah.
put together. Like you can kind of figure out the edges, right? And then the lower half of the image, you can put that together. Upper half of the image is basically a total loss. It's just
I
kind
can
of
go
a lot of
out on a
trial and error.
cloudy day.
Cl
I'll go up there
Cloudy
on a
day would
cloudy
work.
day, and I'll take another picture with some clouds.
That would help a lot probably. So,
Yeah.
but we'll come
Or
up with something.
Photoshop them in. That's quicker.
Yeah,
Yeah.
yeah. Make AI add the clouds to it or something.
Yeah.
All right. Hi, Louis. So let's just finish that part. I did do a couple of things that we didn't have time for in the last call because in the last call I wanted to get to far enough, and of course I say that and Unity crashes. So ran it once, it was fine. Ran it again, and it crashes on me. Anyway, so last time I was
Hello.
speeding through a couple of things because I wanted to get to far enough in last call for um, the pieces to snap together before we got done with that call. But there were a couple of little issues that came up on the last call. One of which was there was a networking issue, so I sorted that out. But the other one was scattering the pieces around. We had a random scatter, and then we introduced a constrained scatter, but it was pushing them to the four corners because we had two constraints, one up the middle and one down the side, and so it was like excluding both areas. So I sorted that out so you can get a nice scatter around the edges if you want to. That's pretty straightforward. All I did was, where is, oh, that's the server script. All I did there was make it, here we go. Um, Rather than having both constraints on at once, for any given piece, it picks one constraint at random, either vertical or horizontal, and shoves it off to the side, but only on one axis at a time. And so you get to keep whatever the random value was on the other axis that you're not enforcing the constraint on. So that was not a big deal, but I also added it so that you could pass in a scatter parameter to it. So like down here, when it's scattering on startup, it's specifically saying scattering it to the edges, right? I could change that, and if I want to, and return it to just being like a completely random pile. But we're just going to take that out again for now, just because it's going to be easier for us to debug and play with moving chunks around if we can kind of quickly see how chunks are supposed to go together in the first place. All right, so the first order here is just to get this moving things around in pieces. So we talked a little bit about that in the last call, that the approach we're going to use for that is just basically parenting one piece to another piece. So we can start off doing that. We can say over here on drag ended, whenever we drop a piece, right? So whenever we let go of a piece, we're looking through all of that piece's up to 4 connections that it might have, because edges and corner pieces don't have all 4. And we're saying if you dropped it in a place where it is connected to something, then we're like, hey, we found that, and we snap it into place. But we're not doing anything beyond that. So we need to do a little bit extra here. What we're going to do is we're going to first say puzzle info dragging ID, and we're going to give it a parent. So we're going to say we figured out where you're supposed to go, who you're supposed to attach to, and it's value.index. That's the piece that we've decided you dropped it in the right place to connect it, and so we're going to snap it into place. We're going to remember that. It'll be useful to know in the future whether pieces do or don't have parents. So if their parent is nil, they don't have one, and if their parent is a number, then that means they are connected to something. They're a part of a larger piece. And then we're going to parent this to the piece that we dropped it on. Now we have to be careful here because the piece that we are attaching it to might itself also have a parent. So that's something that we actually need to know. So because we don't want like a parent to a parent to a parent to a parent to a parent. If I connect a piece with a larger chunk, then I want all of those guys to have the same parent. It's only going to be one level deep. So what we're going to do there is we're going to say if puzzle info value.index.parent is nil. So the piece that we're trying to attach to doesn't have a parent, then we're going to make it the new parent. So we're going to be like, okay, it was either already the parent of something or it was not attached to anything to begin with. Either way, we're going to make it our new parent here. If it was already attached to something, then instead of it becoming our parent, we are going to copy its parent. We're going to take on the same parent that it already has. And so then we're going to actually, that's just us making a mental note. That isn't actually changing the parent. So then we need to actually change the parent in order for this to be useful. So at that point, we're going to do puzzle info, dragging ID, dot container, set parent. Who are we going to set the parent to? Well, the parent is going to be equal to puzzle info. This is a little bit all of this to figure out who our parent is supposed to be, and then we're going to parent to its container. But we put a true on here, which means for Unity's standard set parent function, that means maintain relative world position. So it yells at you if you try to leave that off. Okay, so that is now going to actually attach a piece to another piece. That's kind of half the battle. So if we go look at what this does, if Unity will kindly not crash on me. Let's see what change that had to our puzzle game here. So we have this guy, we drag him out. Nothing much happens with him, right? We can see like they grabbed it, they let it go, cool. We go over here and look at our puzzle piece. That was piece 73 that it says. So I'm going to go find piece 73. Nothing special going on here. So we can see piece 73 and 74 on this side. Now what should happen is when I grab this other piece, like I can move him around, that's fine. But when I move over here and I attach him to piece 73 and let go, you can see that, hey, they grab puzzle piece 85. You drop this near its left connection, cool. And then I go up here and I look in the object hierarchy, and I can see that piece 85 is now a child of piece 73. And that's going to kind of halfway do what we want. So if I pick up and move piece 73 around because 85 is a part of it now, then that actually moves around with it. But the same is not true if I pick up piece 85. If I grab the parent, it works right. If I grab the child, it doesn't look like it works right at all. And this is now just essentially broken because it thinks it's part of a chunk, but it's not moving the whole chunk around. So there's obviously some issues there that we need to resolve out. Like saying I can attach something on that side, and I can attach something on that side, and so we've got kind of halfway there, but we can only works if we drag specifically the parent. So let's see if we can improve upon that a bit. Let's go ahead and stop Unity over here. So what we're going to do there is when we start dragging the object around, right? We're going to, when we pick up an object, we say, okay, we started moving something. One of the things we do is we specify what the drag object is, right? So that's just literally what is the actual game object that we're moving around. So when we can come over here where we say, or we're looking to see if we've picked a piece up, right? Have we clicked a piece? Is it a piece we care about? Is it a piece that's not already being moved, and so forth? And then if all of that's okay, then we say, okay, well, we're dragging around the container of the object that we clicked on. But what if instead we say, all right, but what if puzzle info clicked ID dot parent is not nil? What if the piece I click on has a parent? Well, in that case, what we're going to do is we're going to set drag object to be actually not all of that. It's going to be all of this again. So we're getting, we want the parent. So we're going to get puzzle info, the parent of the piece that we clicked on. Actually, I think we can simplify this a little bit because I think clicked piece is already returning the whole thing. So we can actually simplify this down a little bit. We can say if clicked piece dot parent is not equal to nil, this will be less confusing to look at. So we can do puzzle info parent container rather than my own container. So from now when I click on a piece, I go, are you part of a set? Do you have some larger group that you belong to? And if you are belonging to a larger group, when we drag you around, we always want to drag the masterpiece around, the parent of that entire set. But if you're not part of a set, then we're just dragging you around by yourself. So let's go see what that does. All right, so we should be able to pull out a piece here. It's piece 85 again. Just I apparently clicked a random. Snap you on there, snap you on there. And if we look at piece 85, which was the one that I snapped it onto, we can see that it has two children, it has 97 and 73. Something we should be able to see here is if I grab this piece, if I move it here, this is actually connecting to a child piece, but when I let go of it, it should go, oh, you connected to a child piece, so I'm going to parent you to that child piece's parent. And that is apparently not quite working right. I know why that is, but we'll get back to that. Let's see how dragging works here. So it still works that if I click on the parent and move it around, I'm moving the whole set around. Let's see what happens if I grab a child. Oh, I can grab any of these pieces now and it drags the whole set around as a result. So that's good. Now, what's the issue with snapping pieces here, right? Like I can't get this to snap now for some reason, even though that obviously fits. I can still snap stuff to the parent. That works. But I can't snap anything to children. So that's a little bit of a problem. So the reason that's happening is because we're changing the parent of these, their local position is not predictable anymore. That it's not their local position is no longer relative to the puzzle's parent. It's relative to the piece that they clicked on. So we should be able to solve that relatively easily. We can come over here, and what we can look for is we have a series. We know offset values, how far away pieces were supposed to be from each other. But currently, we're comparing that offset to local positions. And so in this case, whenever we put two pieces together, then we're comparing a local position of two objects with two different parents. And that's rarely going to work out in a way that's useful. So what we're actually going to do is we're going to change these to world positions. We're going to do that. And let's do that. And let's see how that works out for us, just switching over to world position. Because world position doesn't care who your parent is. That's just the global position for everybody. So I pull this piece out. I can snap you on there. I can move that around. That's great. I can snap more stuff onto the parent. That works out just like it did before. But let's see what happens if we can attach to, yep, that now attaches onto there. So we've got that. What was the original piece I grabbed? I think it was 85. No, 85 is now parented to something. What was the first piece I grabbed? 97 was the first piece I grabbed. So it's currently the parent. And if I go look at 97 in the object hierarchy over here, we can see that it has 3 children, which makes sense. This is a set of 4 objects. So that's one parent with 3 kids. And I should be able to just add as many pieces onto this as I want to now. And I can move this whole chunk around, and I should be able to make multiple chunks, right? Like I can pull this guy over here, and I can be like, well, you attached here, right? So I've got a chunk here, and I've got a chunk here, and I can grab and move any of these pieces. So then there comes the question of like, okay, that's cool. Can I get chunks to attach to other chunks rather than individual pieces? What happens if I try to do that? So let's make a new chunk here. And so we've got this little guy here who theoretically should attach onto here, right? So if I grab this and I drag here, that doesn't do anything. If I grab this and drag here, that doesn't do anything. So we have a little work to do here with getting chunks to attach to other chunks, but we can now at least make individual chunks. I actually pulled that one off and had it reattached to another guy, which is, yeah, special. So let's see what we're missing there. That one parented to itself when I snapped it in place. Normally the puzzle wouldn't all be in a place where pieces could do that, but that's fine. All right, so chunks attaching to other chunks. This is a little bit more complicated, but basically it amounts to, yeah, you're not going to actually going to snap. Our goal here is to get it so that connections are always based on the piece that we're dragging, right? So if I drag this piece down, and because it's the piece that I'm currently selecting, it doesn't matter whether it's moving the whole thing around or not, right? It just purely for detection purposes of what am I snapping to, we're going to stick with what is the piece that I originally clicked on, not necessarily what is the piece that is the parent of that set for moving purposes. So we've got that. Let's go look at our script over here. We are still, even though we're dragging parents around as the drag object, the dragging ID is still the original piece that we clicked on. So that's useful to have. And that's also what dictates what piece is being moved. So there's going to be some work to do there later around the networking side of things, because we're going to want to, we don't want two people to try and move the same chunk by clicking on different pieces. If I click on piece 97 and you click on piece 85, right now it would currently let us do that because the dragging ID is based on the piece that we clicked on, not the whole unit. So we're going to want to update this later on the networking side so that the piece that's being reported as moving to the server is the parent, even though that's not the piece that we clicked on. That way the whole chunk is reserved for me, not just the actual, not just one member of that chunk that I decided to move around. So that's, like I said, some of the less fun, more tedious stuff that we'll probably do off camera later once we get this kind of basically working the way we want it. Because everybody complained that the part 2 was really dry and boring to watch with all the networking stuff, so we probably won't do another networking segment, but that part will still have to be kind of finished up, put a bow on that later. All right, so chunks connecting to other chunks. Let's see what we can do with that. We've got it detecting world position for a single piece. We're checking to see the piece that we were actually moving. We let it go. We go through all of its connections. We're looking to see if it's near anything, let's see if this actually should be working. Let's see if because we don't get anything. You dropped it near its. Okay, I see what's going on. You can see down here, it says you drop this near its top connection, right? Which is sort of technically true. When I pick it up and I move it around and I let go, it is near its top connection, right? But we need to exclude any connections that are already formed, right? That's not useful if every time I move this for the foreseeable future, it goes, hey, I found the top connection. Like, I know, it's already there. So that's just let's go back here to the script, and we're going to add some extra checks here, right? So we want to know if the piece that we dropped it near is already part of our chunk and not somebody else's chunk. So we could add this into the same if, but we're kind of going off screen here. So I'm going to add it to a nested if just so the logic stays separately and it's easier to follow on screen. So what we're going to do with that is we're going to say, okay, well, how do we know if it's part of the same chunk? Well, one of two things will be true. Either we'll have the same parent, right? If my parent is equal to the parent of the piece that I dropped it next to, we're in the same chunk. We have the same parent. The other way that can be true is if one of us is the parent, right? So that actually can be three different things, right? That can be if we have the same parent, or if my parent is the other guy, right? Or if the other guy's parent is me. So if dragging ID equals puzzle info dot parent, right? So if any of these three things are true, we're part of the same chunk. Either neither of us is a parent, but we have the same parent, or if I'm the parent and the other guy is parented to me, or if the other guy is the parent and I'm parented to him. Those three cases mean that we're all part of the same chunk, in which case we want to ignore that and look for other connections because that connection is already made. So what we're going to say is if none of that's true, then we can go ahead and consider it as a valid new connection because its connection has not previously been made. So let's go see what that does if we just exclude our top guy, or exclude our existing connections out of here. Oh, we come down here. Let's pick some pieces that are a little bit easier to see. Let's pull some pieces off the side here. I can, you are, oh, right, let's see, this is not working because we forgot to exclude the case where neither of them have a parent, all nils. So what we're going to do with that, we are going to just say if puzzle info dragging ID dot parent equals nil and puzzle info value dot index dot parent equals nil. Or yeah, that should work. So in the case that like both are nil, like neither one has an apparent, or they're not part of the same chunk, then let them connect. Let's see how that works for us. Pull a piece out. Oh, okay, we can attach those pieces. Those are fine. We're back to building chunks here. Yep, so we dropped it near its left connection. We can move this whole piece around. Let's build another chunk down here. Right, we've got this guy. Now I can move this around. That should obviously not do anything. Those don't connect in any meaningful way. If I drag this over here, that's not going to connect because the piece that we were actually clicking on to drag is not the piece that makes the connection. So that's actually working as expected, maybe not ideal. We might want to refine that later, and we can refine it where we say, when I let go, instead of just checking if the piece that I was dragging has any connections, check if any piece in the entire set has a connection, right? But that's kind of like a next step. We want to just see if like what happens if I grab the piece that's actually supposed to be making a connection and I move it over here. It actually does snap into place now and becomes part of the whole thing. Now that's not quite right, even though it looks right. A couple of things were kind of just fortuitous there. If we look at the piece, so they grabbed piece 2. We gotta figure out what was the original piece that we grabbed. Was it piece 6? So if we look at piece 6, something's not quite right with piece 6, right? This is a set of 1, 2, 3, 4, 5, 6, 7, 8 pieces. That means it should have 1 parent and 7 children. But if I look at piece 6, it actually only has 4 children. So that doesn't make sense. And it doesn't make sense because the rest of the pieces are actually still parented to the parent of their original chunk. And so we've gotten like a hierarchy going here, which is not what we're trying to build. And that only sort of looked like it worked because the piece that made the connection happened to be the parent. If it wasn't, this would have worked not nearly as well as it seemed to have. I'll show you what I mean. If I pull out, let's see if we can make a piece here like this, and then this, and then this. All right, so we've got this piece over here, this chunk, and the parent is going to be one of these top two pieces. It's not going to be the piece that's on the bottom. So if I drag this down here and I connect it, we can see that because the connecting piece wasn't the parent piece, then it actually separated that piece from its chunk, and those pieces were left orphaned. So we're getting sort of inconsistent behavior when we connect chunks together. And that's expected because we're missing one part here. And that part is that when I reparent the connecting piece to its new chunk, I need to reparent all of the pieces that belonged to that as well. So we have to figure out, okay, well, where are all the pieces that, whether I was a child of a chunk or whether I was the parent of a chunk, then all of my chunk mates have to come over with me to the new bigger the combined chunk that we're making of the puzzle here. So how do we do that? Well, what we can say is we need to first figure out whether it was a parent or whether it was a child of a chunk, if it was even part of a chunk at all. So what we're going to do is we're going to kind of make our lives a little bit easier here. So far, we've only been keeping track of parents. We really should be keeping track of whether parents have children, because that will make our life a lot easier when it comes to merging chunks together. So what we're going to do here is we're going to say, all right, we're deciding who our parent is going to be when we're putting pieces together, right? So once we've done that, then we can say, okay, well, let's look at the parent then. If puzzle info, whatever we've decided our parent is going to be, if they don't have any children that have been defined ever, they have nil children, then let's make them a nice little children's table that we can put stuff into. And then we're going to insert into that children's table ourselves, whatever dragging ID is. We're now telling it, hey, not only do we now have a bi-directional reference, I know who my parent is, and you now know who your children are. So that's useful to have when we're combining those chunks together. So that means that every time now when I attach a piece to a larger chunk, whatever is the parent of that chunk is going to have a table listing who all of its children are. And that's going to make our life a whole lot easier. So we're going to come down here and we're going to say, first of all, we're going to, because we might be combining pieces together, we're going to make ourselves a new variable here. And this is just going to be remembering who our parent was before we attached ourselves to the new guy. So that'll be useful to have. If I had a parent before, then I'm going to need to know who that was, because by the time I get down to here, that parent's already been changed. And so accessing it now would not be useful. But I can say, if old parent is not nil, that means it had a parent prior to me reparenting it. Thank you for the autocomplete there and VS Code. The other thing that might be true is it might have children. So I can look and see if that's not nil, then apparently I had kids. I was the parent of another chunk before I got merged into something larger. So these have to be handled in two slightly different ways, right? So if I had a parent, then I need to go and get all of that parent's children, including that parent itself, and merge him over. So what we're going to do with that is we're actually going to kind of combine this. We're going to say if old parent's not nil, okay, we're going to move this down here. We'll see why in a second. What we're going to instead do is we're going to come up here and we're going to say, if I had children, then I'm actually the old parent. The old parent is me, right? And then we're going to say like, okay, if we get down to here, that means either my parent wasn't nil or I had children, so I decided that I was the parent and put that value in here. So if neither of these things happened, if I didn't have a parent and I didn't have children, old parent would just be nil. There would be nothing there. So if there is something there, all of the children need to go with it. So what we're going to do with that is, okay, first we'll just start by moving all of the children over. So we'll loop through all the children, say C equals 1 for however many children there are. That'll be old parents' children. And then we will say for all of the children, which is going to be puzzle info, old parent, dot children, C wrapped inside puzzle info again, dot container, and then we're just going to do the same thing up here, right? This needs to go to whoever the new parent is. It's basically just copying this again, reparenting all of the children to the new parent all at once. And then we can adjust some parameters on here, right? We can say all of the children, their parent is now whatever my parent is. So it's going to be this guy. Make sure everyone has the same parent. And then as the final thing we're going to do is we're going to say puzzle info, old parent. We also have to do table insert, and we have to say that the new parent, right, which is going to be, basically need to repeat this guy, is going to be, it's not dragging ID, it is going to be puzzle info, old parent, children C. So that says, okay, if you attach a chunk to another chunk, reparent all of the pieces of that chunk to the new parent, and then tell the old parent, hey, you don't have any children anymore, right? Now, this is actually going to create a little bit of a problem, because in the case where we do this and also this, the piece that we were dragging is actually going to get done twice. So that's not terribly useful. So what we're going to do there is we're just going to say, we're going to move this around. We're going to say that the only time we don't want to do that is if there's no parent at all, right? So if there's no parent, then we're just going to do it manually once ourselves, just move ourselves over. But if we did identify a parent, then we're going to get swept up as part of that as well, unless we are the parent, but that's okay because that's actually going to be, actually, let's just do this here. The parent itself needs to go over. So we're going to just add that in here, I guess. We can probably make this a little bit smarter, but if, let's see, table insert, what we want is old parent, whoever that was. Wait, nope, that goes here. That's the new parent. What we want is to change the parent of the old parent in here, because this is only going to get the children. So we want to move the actual parent itself. So puzzle info old parent is going over there. So this will move whoever the parent is going to be added to the children of the new parent, old parent to new parent, and then actually redoing that reparenting. So this actually needs to be, wait, no, I got that backwards. This actually needs to be old parent over here. Yeah, there we go, to the new parent. Old parent on this side, new parent on this side. And this needs to be old parent also. Okay. So in the case that we've identified a parent, whether it's us because we were the parent of a chunk, or whether it was where we have a parent of our own, then we're treating all situations of there is a parent of a chunk somewhere, whether it's us or somebody else, the same. Where first, whoever the old parent was, move them over, then move over all of their children, and then clear out the children of the old parent so it doesn't think it has those anymore. However, if there is no old parent, which should only happen in the case of we're just a single piece that we're moving around, then we're just doing the old behavior of, okay, well, just the piece that I was actually moving, attach it. It doesn't have a parent to worry about. Okay, so that's got vastly more complicated, obviously. It's still not the whole picture. There's still more to do on that. But let's see how we got here on that. So we move this out here. Let's make some chunks. We got ourselves a little chunk going here. And then we make ourselves a new chunk here. And we make ourselves a new chunk here. Now, these move around as chunks, as one would expect. What we're looking for, and there's sometimes this may appear to work correctly still, and sometimes it may not. It's going to work more correctly than it did before, but we're still not 100% of the way there. So let's see what happens if I grab this over here and drop it. We still get the case of there's a gap here now, right? It didn't reposition all of the child pieces, but if we figure out who, let's see, I did grab piece 7. Where is piece 7? Who is your parent now? Okay, so now we grab piece 7 and we dropped it. And so we can see that this is a chunk of 1, 2, 3, 4, 5, 6 pieces that we can move around here. That should mean 1 parent and 5 children. So if we look at piece 5 here, we can see that it is the parent, plus it has 5 children, right? So that part worked correctly. It worked correctly in the sense that we no longer have parents with parents with parents with parents inside of them when we're combining chunks. The chunks do actually combine into one single chunk correctly. The problem we have is orphaning or pieces not being moved correctly. There's also a little issue there where its parent didn't get, let's see, why did you let me pick you up? It didn't think it was part of a chunk for some reason when it got reparented, but somebody's parent is not getting set correctly. Oh, it's probably this one. Yeah, so it should be. Let's clean this up a little bit. So what we're going to do here is we're going to say we've got old parent. Let's figure out who new parent is. So we're gonna have new parent is going to be, we're just gonna declare this as value.index to start off with. We're gonna assume we're parenting it to the object that we just gave it to, or that we just dropped it next to. And if that is only going to change in the case that this is not nil, so new parent is now equal to this. And now anywhere we need to talk about the new parent, we can actually just use new parent, which is going to be, yeah, I know I used you. I declared you, didn't use you anywhere. Boo-hoo. So now we can just say new parent instead of doing this over and over again. So we can clean this up a bit. We can say this should just be new parent. This should just be new parent. Right, anywhere that we have this, new parent, new parent, new parent. Make our lives a little bit easier. Make this a little bit easier to read. Right, that's a little bit cleaner to look at. And so the issue there is, yeah, so we're not actually changing any parents there, which is fine. We're just deciding who the new parent is. And then we need to come down here and say puzzle info old parent dot parent equals new parent. And then we just need to do the same thing down here, except for this is dragging ID. Okay, and we can simplify this a bit more. This is just prototyping. We can clean this up even more than it is, but for right now, we just care about whether it works, not fully optimizing all the code that goes into here. That just makes it easier to read. All right, so that's most of the way there then, right? We should be able to restart this. And we'll make some chunks. My mouse is not cooperating with me here for some reason. My middle mouse button is misbehaving. All right, so we come down here, and let's make some chunks. We just pull these out. We got that, and then we'll make another chunk up here. Right. All right, so we got that. And so now we've got 2 chunks of 4 each. That's 1 parent and 3 kids. We should be able to combine these into 1 chunk of 1 parent with 7 kids. So if we pick this guy up and we come over here and we drop him down, we still have that gap, which is expected. We didn't fix that yet. Let's see where piece 6 ended up. Right, so we've got 1 parent plus 1, 2, 3, 4, 5, 6, 7 kids. And it should be that we can move any of these around, no matter which one I click on. That's the bug we just fixed, was now everything is properly parented. It's all part of the same big chunk. The only problem we have is that little gap is not supposed to be there, right? So when we're snapping into place, we're only snapping the piece that we were dragging. We're not snapping the whole thing into place. So we have to sort that out, and then we'll basically have a puzzle, right? So what are we going to do with that? Well, what we're going to do there is, for our snap, what we actually want to do is first figure out how far away from the snap point we actually are. Okay, that's going to be our first thing. So we're going to say, we're going to make a new variable called drop offset, right? And we're going to figure out, this is going to be the difference between where we are and where we want to be, right? So it's our current position minus what all of this is, because that's where we're supposed to be, right? Where we are, what is the difference between where we are right? 'Cause just another name for minus is difference, right? What is the difference between where we are and where we want to be? And so that's useful to have now that we have that. And instead of just immediately moving the drag piece, that might be what we do if there's, if that's the only piece that we're moving around, it's not part of a chunk, we can move that down here. And then we can say, the world position there is going to be the world position, my current world position, plus whatever the drop offset is, right? But in the case of this, what we actually want to do is move the container of the old parent by that drop offset. All right, and that's before we take it apart, right? It was a chunk, it had a parent. We know that anytime that parent is moved around, all of the children of that chunk could get moved around with it. So we just want to make sure that anytime we're snapping a chunk around, oh, you click here, you click there, that we always move the parent, and that's going to always bring our children along with us. And then once we know everything's in the right place, then we can take it all apart and recombine it in the way that it's supposed to go. So let's see if that works for us, and I didn't break anything here. We're going to come over here, make ourselves some chunks again. That's obviously not quite working correctly. I must have broke something because the pieces are snapping to the wrong spot. Well, that's not where you're supposed to snap. This is probably just an operator is flipped someplace. So you can see that, like, when I drop this, it offsets in the wrong direction. So like this should, when I let go of it, move slightly to the left, but it moves slightly to the right instead. So that indicates that there is a flipped sign someplace, which means that it's probably this one right here. Should be a minus instead of a plus. Let's see how that does. All right, let's see if can we build chunks again. That looks better. There we go. That builds a chunk. That builds a chunk. We got ourselves a little chunk. We can move it around no matter which one we grab. Let's build another chunk, right? We can build one up here. Build this guy. All right, we got another chunk that we can move around. We still have the problem that if I drag a piece that isn't the connecting piece, it doesn't snap because it's only doing checking for the piece that I actually clicked on. That's something we can further fix later. But if I grab the piece that it actually is the connecting piece and drop it there, we can see the entire piece now drops into place, and I can move that all as one big block. And I should be able to do that as much as I want. Like, this is what all of the inner piece is here. And so it should be that if I grab this piece here and move it around, that should attach there, right? So I can let that go, and boom, we have a whole big puzzle piece here. And I should be able to just do that as much as I want to. That goes there, and we can just combine the whole thing. Now, normally, if we had this and these were actually two big chunks, right, I could drop this in here, and that would snap, and the puzzle would be finished. But the reality is, all of these pieces out here on the rest of the puzzle aren't considered a chunk because they were never actually interacted with. They were never actually, we just didn't scatter them around, but technically they're all still loose pieces. And so this doesn't actually snap to that until we actually build our own individual chunks. But that isn't a real problem for the game, because the real functional version of this game, the pieces are always going to start off scattered, and we don't have to worry about that. But we can just snap that there now. So that's actually most of it now. That's pretty much most of the puzzle. There's some networking stuff to work out. Like I said, making sure that this networks properly, and we'll probably want to do some special effects. There's something that's annoying every time that I hit play on this. Like, okay, I start off at an angle that I can't really do anything with it. That's annoying. I really want to be looking at the puzzle from a top-down perspective. So that's something that we would want to fix, right? We would probably want to add a camera to this, right? So we would make like Cinemachine, create a virtual camera, put that in here. Where do we want the camera? Well, we want the camera more or less here, right? So I'm going to select that camera and say, edit, or no, game object, align with view. That positions the camera where I was looking, right? And so we would have this camera, save that. The camera's not on by default, but I can turn it on, right? And then my view just snaps to where we want it so that it's always in a reasonable place to be playing the game, right? That's kind of the view we always want to have when we're not looking at the puzzle edge on. So we would have to add some logic that says, when does this camera turn on, right? We need some way for the player to go, oh, I want to play. And they get added to a player list that not only says they're allowed to move the pieces around, but that it does things like turn on a useful camera for them so that they don't have to try and manually position their camera every time. We might want to make that optional because that might be really good for new players, but maybe experienced players prefer to just use their fly cam, right? So we might want to have a little puzzle UI with some buttons on there where we can say, toggle the puzzle camera on and off since I'm a player. That could show some other useful information like a list of who's playing, things like that. So there's a little bit of refinement work to be done to actually, finish it up and turn it into a production game. But mostly we're there. We have a puzzle, and let's actually go ahead and turn the scattering back on, right? So let's just go ahead and get ourselves, re-enable scattering. And this is where we regret our choice of pictures. So we have now all of these pieces scattered around, and we can start putting them together. Like we can see that's a top edge piece. It's going to go there someplace. That's a side edge piece, right? It's going to be there someplace. That's another top edge piece. Doesn't look like it connects to that anywhere. Just kind of looking for more edge pieces. There's another top edge piece. That's not sure that connects to. Oh, that does snap together. So we made ourselves our first little mini chunk there. We've got another side piece. That's too dark. That obviously isn't going to connect to that piece. Let's see what else we got. Can just kind of move these pieces around. Does this connect to anybody? Doesn't look like you connect to anybody. Nope, you go up here someplace, right? You're a top edge piece. Let's see, there's another top edge piece. Do you connect to anybody? No, doesn't look like it, but you go up here somewhere. But basically the puzzle's now in a place where like we can actually play it and complete the puzzle. There's another top edge piece. Some of these are bound to connect, right? No, finding a lot of pieces that don't connect up here. What else you got? There's another one. That's not gonna connect. That connects. Hey, we got two chunks now we can play with. And we got this little guy. Oh, we can obviously tell he's a corner. Oh, he's the corner piece. He's going over here someplace. Yep, that connects. So now we got three little pieces to play with, and that kind of looks like it's. Yep, there it goes. Pop those two pieces together, and we're off and running here. We almost have a functional puzzle. There we go. Snap those three chunks together. Might be useful to be able to like zoom in on it. So I was saying like more experienced users might prefer to have their flight cam because they can kind of zoom in on it and see better whether pieces are aligned properly or not. But yeah, we're off and going here. We could finish this puzzle if we wanted to. We'd probably want to add, as a part of our puzzle UI, and this is something we could look at if people want to do a fifth one on this, is kind of working on that UI. Like, what is a puzzle UI going to have? Well, you probably, like, say you want to have a list of who's playing, a way to opt in, a way to change the camera. You're probably also going to want to have like um, a way to reset the game, right? Like, okay, we finished it, we put the whole puzzle together, and we want to scramble that. We'd probably also want to have a way to pick the image that's on the puzzle, right? When we start a new game, I say like, start a new puzzle, and it can come up and ask and be like, okay, do you want to change the picture before once in between puzzles? Like, we don't want you to change it while the puzzle's in process. So we'd be like, oh, a puzzle's currently incomplete. You either need to reset it or finish it, and then you can change the picture of it. So there's some UI work that would need to have there, and if that's interesting to people, we can do we can do the next one. We can do a part 5 on getting the UI and sort of the player management and image switching portion of it done. But
We did, Josh, sorry to interrupt, but we did talk about also maybe putting a scoring mechanism, so recording which player may have put the piece in, but that may be beyond this tutorial.
That's actually not a lot of work. Once you got the UI in place that shows a list of who's playing, showing their score is not really any harder, right? That's just something else that the server script would keep track of, right? Whenever I connected a piece together, I would just send a message to my server script saying, hey, Josh got a point. And so then it would, the server would just increment the point and be like, everybody, Josh has 5 points now instead of 4 points, and everybody's UI would update accordingly. You'd, what? Sorry, were you going to say something?
Sorry, I was going to say, how do you get around the problem of having to be holding the parent to make it snap? Do you make any chunk that anything you can move in a chunk becomes the parent? I guess that's the way you do it, isn't it?
So we already got around having to drag the parent. That part is sorted out. You can drag any piece. Like when I'm like this,
Yeah.
this has one parent, and it doesn't matter where I click on it, I can drag it around.
But you've still got to use the
But
parent to snap, though, haven't you? Yeah.
No, you don't have to use the parent to snap. You just have to grab the piece that you want to actually snap. It
Right.
doesn't have
Yeah.
to be the
Yeah.
parent, but you can get around that. So what you would do with that is you'd come down here to drag ended, which is getting quite large because this is where most of the action happens, right? And what you do right now, all we're doing is we're looking at the connections of the specific piece that we were dragging, and that's it, right? That's why it only works. Like if I want these two pieces to meet up, I have to be dragging the item that actually has the connection, right?
Yeah.
So what you would do there is you would wrap all of this in an even larger loop.
So the chunk is a whole piece in itself, basically, then.
Yeah, so what you would do there is instead of only looping through the connections of the piece that you were dragging, you would figure out, am I part of a chunk, right? Kind of like what we did down here. You'd say, am I part of a chunk? And if I am part of a chunk, I'm going to look at the connections of every piece in that chunk rather than just my own.
Yeah.
So
it makes it like all the pieces become one piece then. It's no longer a chunk as far as the code's concerned. It's one piece then.
Yeah, so that would happen up here. You would say like first find out if we're in a chunk. And there's some like cleaner ways to do this, right? So we could say, kind of minimize the code that we're writing. What we could do is kind of like that. What we did down here is first we identified the parent and then just always went based off of the parent because the parent knows who all of its children are. So we could do something like that up here where we say, like a new variable, we'll call it all pieces, right? And then we will say that, well, all pieces is going to at least contain the piece that we were dragging, but then find out if it's in a chunk, and if it is, then find out who the parent is, add all children of the parent into all pieces, right? And then we would loop through that. We would say, just like p equals 1, all pieces. You could simplify this a little bit by doing the same thing we did before and say key, or this would be, I'll just call this p and piece, and in the pairs of all, this would actually be I pairs in this case. And so we would have this extra loop in here. And then, this should be a do, not a then. And then what would happen is everywhere down here that you see dragging ID, instead of dragging ID, you'd substitute it with piece, right? And so this inner loop, we would loop through all of the pieces that are part of that chunk, and then redo this inner loop for every piece in that chunk. And so for every piece in that chunk, we'd be looking at its connections. We'd be looking to see if it was, a loose piece, if a connection had already been established, and we'd ignore that connection. And then we're looking for any piece anywhere in the chunk that has a connection that is not currently occupied. And then we could go ahead and more or less do all the same stuff that we're doing here. There might be a couple of extra considerations, but it's really about saying, okay, this is a 6-piece chunk. And so when I'm looking for connections, I have to come down here and I have to say, are you near any connections? No. Are you near any connections? No. Are you near any connections? Oh, you might be near a connection. So the entire chunk needs to snap based on you, even though you weren't the piece that I initially started dragging. It's just go through every single one of these. And as soon as you find any one connection on any one piece that is not yet connected but is close to a connection, then you can snap the whole chunk into place.
Wouldn't that cause problems as well, though? Because when you are going to drag that chunk, it's liable to have a load of connections.
Doesn't matter. You only need to find one.
No.
Yeah.
Yeah.
No, it doesn't matter at all. As soon as you find the first one, we're already doing that, right? So like you can see down here, every existing piece can have up to 4 possible connections, right?
Yeah.
It's a grid, so you can have a top, a bottom, a left, and a right. Some pieces will have all of those, some won't, but there can be as many as 4 possible connections. And so it's possible that I could drop a piece down in such a way that it's near all 4 of its connections. But that's not a case that we've decided that we're going to handle. We're just going to see, like, we're going to do one connection at a time. And so that's why as soon as we find a connection that's valid, we break. We say, like, that's it. We found one connection. We're done. And most of the time, that's going to be enough. The only time, because like if I've got 2 big pieces, this is easier to show if it's not scattered around because I can build pieces easier. So I'm just going to turn scattering back off and restart this. So let's say, we just build two crazy chunks here, where I just say, like, I've got you. I probably broke this code by, hold on a second, adding this extra unfinished for loop in here is probably going to break this code. So hold on a second, let me just undo this part real quick. Put us back to where we were. Okay. And we play that again. If I just make some chunks out here, right? Gonna make this guy, there's a chunk, and then I'm gonna make like another chunk that goes around him, right? There's a chunk. I I want to put these two chunks together. And so if I'm doing checking for that, if I drop here, right, that's going to be 1, 2, 3, 4, 5 connections join these pieces together, right? There's 5 relationships that are suddenly all in conjunction with each other. But it actually doesn't matter because we know that if I snap 2 chunks together, the entire chunk snaps, right? And so, like, let's say I'm dragging this top piece and it finds a right connection. It says, okay, I can see that that connection right there is bridged. I'm going to stop looking. That's all I need to know. Because once I know that like these go together, then I'm going to bring my whole chunk with me, right? So I'm going to like, okay, well, to snap, I need to move over and down a little bit. So I'm going to do that. I'm going to snap in place. And because I'm snapping
Yeah.
the chunk in place, all the other pieces are also snap into place, right? They're
Yeah.
also where
Yeah.
they want to be because they were aligned up properly with the chunk in the first place. And
Yeah, they're not
so,
having to snap really, are they? It's
yeah,
they're just following the other piece.
yeah,
As long as one snaps, they all snap, kind
yeah,
of thing.
as long as we're
Yeah.
following the leader, they all snap into place, and that's all that matters. And that, no matter how complex the chunk is, no matter how many connections get formed, if we only need to find one valid relationship, and then we can just assume all the others are valid because this chunk wouldn't have been created in the first place if those relationships weren't valid when the chunk was built, right? Once the relationships are built and those connections are made, they're good. We already verified them. All of those are accurate and positioned relative to each other the way they're supposed to be, or they wouldn't have formed a chunk in the first place. And so we can just assume any one connection means the whole chunk is properly connected, because there will never be a case where that's not true. So yeah, that extra step is really just about looking for that one connection in more places than just the guy that I'm dragging. Because right now, just the guy that I'm dragging, whoever I click on, I'm still dragging the whole chunk, but whoever I click on is the one that's deciding whether we are near one of his remaining connections. And so it's not about finding all the connections. It's just about going, okay, well, you weren't near any connections, but what about the guy under you? Was he near a connection? Well, what about the guy under you? Was he near one of his connections? And again, you only have to find one connection on any one piece, and you be like, oh, that's it. I got it. Those pieces go together. Those chunks all merge. We can just make a lot of assumptions because we did a lot of verification already up front.
Josh, are we going to reach a maximum? Say, for example, you've got a huge chunk with a majority of the puzzle,
Yep.
or the whole puzzle's assembled, and you've got 2 pieces to put together. What about the maximum number of sort of chunks to scan through before it starts getting to a lag situation, or do you think that's not going to happen?
It's a valid concern. If you had a 1,000-piece puzzle you were putting together, and you were moving a chunk around that had 420 pieces in it, then
Yeah.
you're like, oh, I got to look at all of these? Damn.
I mean, it's unlikely, but you could end up being up to piece 410 before you get a connector kind of thing scenario.
Yeah, so there's some optimization that would definitely have to happen around that, which is kind of a bigger topic. You can run it. There's ways you can minimize it. One is, for example, if I snap these pieces together, I've got this nice little chunk here. Something I can think about in the future is that if I were to try and snap this chunk to something else, do I really need to look at every piece? The answer
You just need to look at the outer edge, don't you? The edges that can line up. If it's got an edge border, for example, the left and the bottom, you don't need to check that at all.
Right.
But potentially you could be. Yeah.
Right. But it's not just the borders, right? Like, do I need to check this
It's
guy?
the center as well. Yeah.
Yeah. He doesn't have it. He's
it's
done,
already
right?
connected.
Yeah.
You only check on the opposite side.
So I could put a lot of optimizations in here where, for example, when I put these together, I can be like, oh, all of your connections are met, all of your connections are done, and any connections that you had, right? You might have only had two or three, or you might have had all four connections, but I've checked now, and all of your connections are completely finished, and so I can mark that piece as being done. And
Yep.
then when I'm looping through all the pieces later, instead of repeating this inner loop for every piece, I can only repeat, I can say, oh, well, I'm only going to do this whole inner loop if the piece is not marked as done. And I still have to look at it. I
Yeah.
still have to look at that piece and go, are you done? But
Yeah.
the calculations that the computer has to do to check a Boolean, right? Is that true or false? Is
Yeah.
way less than the calculations it has to do to run this loop. And so
Yeah.
I'm drastically reducing the cost of every piece in a chunk that doesn't have open connections on it. So
Yeah.
there's some
That's the key,
optimization.
isn't it? You're detecting the opening connection, the open connections.
Yeah, and but that still might not be enough. Like that's would be necessary, and it's a great first start. Is going like, okay, do I really need to look at all of these pieces? I could save myself a lot of processing time per frame if I realize that some of these pieces, like they're just not important anymore, and
Yeah.
just skip them over. But still, if you had a sufficiently large puzzle, you know, like if I had a puzzle, like I mean, what if I do something like where I do, you know, I've got the entire inside of this puzzle, right? Something like this,
Yeah.
where I've got a lot of open connections, and this is only a 192 piece puzzle, right? I could have some
Mm.
pretty gnarly. Um, I'm ignoring a lot here, right? If I were trying to move this whole chunk around, I'm ignoring like all this stuff in the middle that's already connected, but I've still got one, two, three, four, five, six, seven, eight, nine, 10. You know, there's 40 or 50 pieces here that I still need to look at for
Yeah.
a 192 piece puzzle. If I've got a 1,000 piece puzzle,
Hmm.
there still might be a couple of hundred pieces that I need to look at to see if they have connections. So there does come a point where you might have to say like, oh, okay, this is going to have to go in a coroutine, right? It's too
Yeah.
much for
Yeah.
one
I thought that
frame.
was going to be the.
Yeah, and
Yeah.
and so if that happens, then you need to change the logic a little bit. You'd have to make it so that um, basically you have to just put a weight in here. You could because if we put this all into a coroutine where we're checking for connections, then we run the risk of while that's going on, while it's still looking for connections of the last piece you dropped, you go and pick up another piece. And so what we would have to do is we would have to institute like a hold where you say, okay, like I'm starting a coroutine. I don't know how long that's going to take to finish, but so long as that coroutine's going, you can't pick up any more pieces. We have to wait for that
Yeah.
coroutine to finish, and then you can pick up another piece. And so then we would have to have like some visual indication to the user, like a little busy symbol popping up on the screen saying it's thinking, right? The puzzle's still working out your last move. And realistically, even in a coroutine, that's probably, for a super complex puzzle, that's going to be like half a second, right? Rather than
Yeah.
instantaneous. So it's not a big deal, but it's something we still need to, it's not going to drastically slow down the user's experience. And you kind of optimize that down as much as possible. The coroutine's only going to take as long as it needs. And so you'd only see
Yeah.
like edge case long waits if you were moving around these giant open pieces. So it wouldn't be a big deal, but you'd have to like be like, okay, hold on, you got to let me finish before you can make another move, right? And you'd have to do that for everyone. You'd have to network that. You'd have to wait to send the release message, like user release this piece until it was done with that thinking. That would be basically the only change there on the networking side. Instead of us saying, hey, we let go of this piece the moment we let go of it, we would only say we let go of this piece when we were done thinking about it. and we were sure that we had gone through all of its connections first. So this would move from being at the end of we let go to being at the end of the coroutine instead. That would be the only thing that happens there, and that way other people can't pick up that piece that we're still thinking about as well. So there would be a little bit of stuff to kind of some nuance. That kind of depends on just like how intense this is. Like the more complex we make this, then the more time it takes to look at each piece. And so there's going to be a limit where we reach where we're like, oh, this is causing frame lag when I let go of it because I'm looking at too many pieces on a single frame. And we're already doing some optimization here, right? We already had to not look at pieces that were, existing relationships on the piece that we're dragging. So like if I drag this piece around, I'm already only looking at 2 relationships anytime I drop it because I know that the other 2 relationships are already filled. So we would just have to just kind of carry that forward.
It's amazing how complex it's got. Not complicated to understand, just complex in the whole sort of the path, everything you're doing.
You guys all thought a puzzle would be easy.
Yeah. I mean, that's exactly what I was going to say. Who thought it was going to be this complicated when we started this 4 weeks ago?
Yeah,
I did actually.
Yeah.
I was surprised when you said you would do it, Josh, because I thought there would be some. I mean, it's complicated. Yeah, I'm agreeing with you, Simon, but it's not complicated to the depth I actually expected it to go to.
Oh yeah. I mean, it's understandable. It's just it's like you're playing a game of chess, but you're thinking of all the moves before you've started playing.
Yeah, and I mean, it helps if you aren't experienced with it and you're not comfortable. There's a joke that goes around. There's two kinds of developers, right? There's planners and there's pantsers, and the planners sit down and they work out a flow graph and everything they need to know. It's like, this is going to happen when I go here, and so they build a blueprint, and then when they get to it, they're just essentially constructing the blueprint that they already came up with and just writing the code that makes that blueprint a reality. Those are the planners. And then you have the pantsers, and the pantsers are people who fly by the seat of their pants, right? That's where that comes from. And they just make it up as they go. I'm pantsing it here. Like I do that a lot, especially when I'm prototyping, is, something new, is I'm just sitting down and I just start whacking out some code and going, all right, well, that's got to be a thing that we have, and that's got to be a thing that we have. Like, we got to be able to move the pieces around. That's kind of basic, so let's just make that work. And then it just evolves, right? It evolves from simple to more complex as you work it out in real time. Versus,
I think the pantser is more fun.
But the planning part can be boring. But projects, there can reach a point where like a project is too complex to do that with. And so
I remember
you have to do some planning at least.
Back in the days when computers were ancient and I was much younger, you didn't even go near programming code until you got a perfectly working flowchart.
Right, and those are the planners.
Yeah.
And for sufficiently complicated projects, whether that's just complicated for you or because it's genuinely, really complicated. Sometimes you have to do at least a little planning, and then maybe you can pants it after that, but you got to do a little bit. I do have to go though, because I have another meeting starting, so I'm going to go ahead and stop the recording here.